Going to look at the trap rule today. So for the trap rule, the formula is h over 2 is equal to a bracket y from dot 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 1. This is found in your log tables page 12. So basically with this rule, it is giving you an approximation of the area underneath a curve. So I'm going to go through a few examples so it'll make sense to you and how you can apply the formula. So first of all, I have here the estimate the area of a piece of land shown below. Okay, so it's given here. I have my curve, and as you can see here, my first height is 5, then I have 4, 5, 7, 4, 9 and 6. Okay, right, so the common distance between these is always my h value. Okay, so the common distance between all of these here is 4, so my h is 4. My first height, okay, that's going to be y1 is equal to here, it's 5. Okay, so the curve starts up here at 5. If it was down here, it would be 0. Then I have my last height, which is yn, is 6. So then I fill in my formula. So my formula was h over 2. So we just figured out here that my common difference h was 4. So this will be 4 over 2. Bracket, it's going to be my first and my last height. So my first height is 5, my last height is 6, plus 2 times all the heights in between. So it'll be 4 plus 5 plus 7 plus 4 plus 9 here. And then I'm left with 2, bracket 11 plus 2 times 29, and inside that I work it out, it's 69, and I get 2 times 69, and my answer will be 138 meters squared as an approximation of the area underneath that curve. Part 2 then, I have this graph. Okay, so it's in your book, it's example 10.24. So I have here, my graph is after starting down here at 0, okay, and it finishes down here, the last height is also going to be 0. Right, so the common difference, that's going to be my h, so the common difference in this case is 3. So my first height is 0, my last height is also 0. So filling into my formula, h over 2, so I have 3 over 2 bracket. My first height is 0, my last height is 0, plus 2 times all the heights in between. So I have 2 plus 3 plus 4 plus 10 plus 7 plus 1. All in here, I worked it out, so I have 3 over 2, bracket 0 plus 2 times 27 when I add all of those heights up. And I get 3 over 2, bracket 54, and my final answer then is going to be 81 meters squared. Okay, so now I'm going to take a look at example 10.25. So I have here my first height is 10, my last height is 0, and I'm actually given the answer in this case, so I have the area is equal to 800. I'm not given, okay, what my h is equal to, so I think I'm going to be looking for my h here. So I have here basically right on my formula, I have h over 2 bracket y1 plus yn plus 2 times y2 plus y3 plus y4 plus dot 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 yn minus 1. So I have here h over 2, I don't know what my h is, bracket my first height is 10 plus my last height is 0 plus 2 times 20 plus 30 plus 15 plus 10. And I get that answer should be equal to 800. So I have h over 2, 10 plus 0 is 10, plus 2, and I add the brackets up here, I get 75, and I know that answer should be equal to 800. So I have h over 2, 10 plus 2 times 75 will give me 160, is equal to 800. So then what I have is, okay, so h over 2 is multiplied by 160, so I want to get h over 2 on its own, so I'm going to divide across by 160, so I have h over 2 is equal to 800 divided by 160. And then I'll have h over 2 is equal to 5. I want to get h on its own, so this here has been divided by 2, so I'm going to multiply by 2, so I'll get h is equal to 5 times 2, and I'll get h is equal to 10 centimeters.